Okay, so today's lesson is about graphing rational functions using 6 steps. This would be considered the warm-up. So this will be a shorter video. Basically, this is page 1 and 2 of the PDF that's posted in Schoology. So you want to start with the directions in your graphing calculator. So you're going to graph each of the functions in your graphing calculator and see if you can determine the correct, accurate graph based on what you're seeing. You probably want to use your table function in your calculator as well. So for example, I've put the function for number 2 into my calculator. And notice I have all my plots are off, none of them are highlighted. And Zoom 6 is normally a good window. If you do Zoom 6, you'll get this window right here. You may have to adjust if you can't see all the curves, but Zoom 6 is normally going to be a good window. Okay, so in order to get this graph down on paper, it looks like there is some sort of vertical asymptote in between the 2 curves and a horizontal asymptote in between the 2 curves. If you go to the table function, right here at x equals -4, you get an error. That tells you that there's a vertical asymptote at x equals -4. Get a couple of points to plot. Usually looking around the vertical asymptote will be some nice points to plot. They won't always be the integer numbers, but that's generally a good place to look for points to plot. Now, I'm not sure about the horizontal asymptote, and you're not really going to find that definitively in the table. So what you can do is if you go to y equals and drop down, let's say I want to guess, I think it's a line y equals 1. So if I take that in there and hit graph, well, that's not right because it crossed this curve over here. So let's go back. I'll adjust that to y equals 2. And that looks much better. If you want to zoom out, expand your window to see if, it needs to be adjusted again, but that is the correct asymptote. So you want to take a few minutes, pause the video, try and work your way through the 6 functions, see if you can use your calculator to get the right asymptotes and some corresponding points, and then start the video again to check your answers. So the first function is your very basic y equals 1 over x minus 5. You have a vertical asymptote at x equals 5, a horizontal asymptote at y equals 0, a couple points that you can get off your calculator from the table to get your curves. You're always going to have curves around your vertical asymptote. So if there's one vertical asymptote, you'll have some curve to the left and some curve to the right. And your domain and range, your domain will always be based around any vertical asymptotes, and then the range will correspond to the horizontal asymptote. Notice we're using parentheses because of the asymptote. So it goes from -infinity to the vertical asymptote, and then from the vertical asymptote to infinity, and the parentheses are needed because the asymptote says that you can actually use 5. And then the range, of course, uses the horizontal asymptote. So for number 2, again, we only have one vertical asymptote at x equals -4, and then a horizontal asymptote at y equals 2, curve on either side of the vertical asymptote, domain tied to the vertical asymptote, range tied to the horizontal asymptote. For number 3, getting a little bit more complicated, you can see that denominator is the difference of squares. It can be factored. So it actually ends up giving you 2 vertical asymptotes, x equals -3 and x equals 3. There is one horizontal asymptote at y equals -2. Again, there should be a curve around every vertical asymptote. So since there's 2 vertical asymptotes, there's a curve on the left, a curve between, and a curve on the right. Again, you can get some points from your table in your calculator. So your domain would be negative infinity to the first vertical asymptote, and then -3 to 3 for in between your vertical asymptotes, and then 3 to infinity to the right of the second vertical asymptote. Your range, negative infinity up to your horizontal asymptote. And then instead of it being your horizontal asymptote to infinity for the rest of it, this point right here wasn't the origin. It was something just slightly above the origin. So there are no y values between the horizontal asymptote and the origin. So it would be from 0 to infinity, but it doesn't actually include 0. For number 4, again, we have two vertical asymptotes. The curve between is a little different than we just saw. So it's more of a negative cubic function than a parabolic function. So that happens as well. But again, you have a curve to the left, a curve between, a curve to the right. Your domain is based around your two vertical asymptotes. And in this case, because of that center curve, your range is negative infinity to infinity. So then for number 5, we can factor both the numerator and the denominator. Hopefully you remember from your limits that when you have a factor that can be reduced, that creates a hole. So instead of a vertical asymptote at x equals 1, it's a hole at x equals 1. And if you take that x equals 1 value and plug it back in the remaining factors, you get 2/8. So that means that when x equals 1, y would be 1/4. So the hole is at this point exactly. Just the one vertical asymptote, because this is just the remaining function right here. So just one vertical asymptote, the second vertical asymptote turned into a hole, and just one horizontal asymptote. So only two curves, but the curve to the right has a hole in it. The domain is going to be related to the vertical asymptote and the hole. Same with the range. For number 6, so we only have the one vertical asymptote. For this one, you actually want to divide, long divide that we've talked about previously. And if you do your long division, we discard the remainder. So what we end up with is instead of a horizontal asymptote, we get a slant or oblique asymptote, which is the line y equals x minus 5. Okay, so we have the vertical asymptote at x equals -1. Then we have this slant asymptote. On this one, you would need to adjust your window to see this curve down here. I adjusted it just down to -15. You could go a little lower if you want. The highest point on this curve down here is at -4, -12. That's going to be important. And the lowest point on this curve is at 2, 0. So your domain is again tied around your vertical asymptote, but your range in this case with the slant asymptote is -infinity, and then the y value of the highest point on this part of the curve, and then the y value of the lowest part on the upper curve to infinity, and use brackets on that highest y value and lowest y value because those points actually do exist on the curve. So then there were a couple questions about, can you kind of make a connection between how you're getting your vertical asymptotes and how you're getting your horizontal or slant asymptotes. Your vertical asymptotes are always going to be tied into your denominator. So if you set your denominator or the factors of your denominator equal to 0 and solve, you'll get your vertical asymptotes. As you saw in number 5, if you can simplify, then that factor is not going to give you a vertical asymptote. It's going to give you a hole. Now, I don't know if you made this connection or not, but the horizontal or slant asymptotes are actually tied into your limit as x approaches infinity rules. And so if you went back through the functions, you'd see that if it was a rule 1 where the degree of the numerator was smaller than the degree of the denominator, you just got a horizontal asymptote of y equals 0. And if it was a rule 2 where the degree of the numerator and the denominator are the same, then the limit to infinity is the same as your horizontal asymptote. And then number 6, where we ended up with this slant or oblique asymptote, that was your rule 3, where the degree of the numerator was less than the degree of the denominator, or sorry, more than the degree of the denominator, and you have to long divide. So then we just had some long division practice here at the bottom, because you'll need that whenever you are trying to figure out a slant or oblique asymptote. Again, once you get to the point where you have a remainder, there's nothing else to bring down, you're just going to forget about that. So if we were trying to graph a function that used these polynomials, we would long divide, and our sign asymptote would be the equation y equals 2x plus 6. We won't get into anything this complicated, but this would be a parabolic asymptote. So the long division is when you have a function that fits into a rule 3 for limits to infinity, and you have to long divide to get a slant or oblique asymptote instead of a horizontal asymptote. Okay, so this is it for this video. The next video will go through the 6 steps for graphing rational functions.